Okay, here we go with page 5. Again, this is one of those problems that you basically only see on the exam. This is L'Hopital's. If we plug 1 into the denominator, we get 0. If we plug 1 into the numerator, we have the integral from 1 to 1. Doesn't even matter what's in the integrand. The bounds are the same, so that's going to be equal to 0 as well. So L'Hopital's rule comes into effect, which means that we keep the limit, and then we have to derive the numerator and derive the denominator. The numerator derivative is very easy. Remember, we're just taking the x and popping it into where t is. So we end up having e to the x squared. And then the denominator, the derivative of x squared is 2x. The derivative of the minus 1 is 0. So there's our new limit. Now when we plug in 1, we have e to the 1 squared over 2 times 1, or e over 2. The answer is B. For number 15, the figure above shows the graph of f. If f is equal to the integral from 2 to x of g of t dt, which of the following could be the graph of g? Okay, so what is this saying right here? This is saying that f prime of x is equal to g of x. All right, if we derive this function, all right, we take the derivative of f of x is f prime of x. And the derivative, because we've got to do it on both sides of the equation, the derivative of the accumulation function just means we take the x and pop it in for t. So f prime of x is g of x. So when it's really asking for the graph of g of x, it's also saying, hey, what's the graph of f prime of x? Well, let's look at this. Here's the graph of f. It's just a line. So f of x is something like mx plus b. We want the graph of f prime of x. What's the derivative of mx plus b? M is the coefficient of x. Isn't the derivative just going to be m? So the derivative of f is just the slope. What's this slope? Well, we don't know. We don't have any numbers. But we do know that the slope is positive. And it's a constant. It's not, slope's always a constant. It's just a number. So we need our graph of g, or f prime, to be a positive constant function. In other words, it needs to be a horizontal line. That's what constant functions look like. Right? A constant function would be like y equals 8. Right? You go up 8 units, and there's your, oh, that's a horrible line, but you get the idea. Okay. So it's a horizontal line, and it's got to be above the x-axis. And we only got one choice, and that's A.